Hey, Joyce.
Hi, Joyce.
All right, here we go. Section 2.1, rates of change in limits. Average rate of change. Come on, my physics people, or even my calculus people. Average rate of change. Why is it an average? Poor K.
Because it's not instantaneous.
It's not instantaneous. It's in between. In between what?
2 points.
Start and end. So it's over a time interval.
Could that also, sorry, maybe a dumb question. Could that be rewritten as dy dt?
No.
It's delta. So it's changing y changes
Okay, that's
t.
the,
It's not the derivative.
oh, you're right. It doesn't have a limit.
So it's actual delta y over delta t over delta t of an actual function. And if that function is varying and not linear, it's technically going to be a secant line, right?
Yeah.
Technically. Because it is a slope. It is a slope. But if it's over a change in time, if it's between 2 points, and if that motion is not linear, well then, right? It's going to be a secant line.
Yeah.
So we could also say that the average rate of change is another way of just saying slope between 2 points. What? Go team. Now, instantaneous rate of change. So Gerardo, bring in what you were saying. You were like, oh, isn't that dy dt? Well, no, not really, but I am going to talk about dy dt right now. But what do I need in order to get dy dt? Hence, the change in y over the change in time of, presumably something not linear, but that's okay, at one time. What do I need?
The limit at, limit as x approach, or no, this would be t. Delta t?
Delta t. Right? Because delta t is the distance between the 2 points, and I need the 2 points to get infinitesimally close. But I could go ahead and still use that difference quotient. True. Which is the exact same thing as the definition of the derivative f prime of t, hence why I have dy dt. Now, just because I can, and just because the AP does, what if I was to ask you just because. So much different.
Because we're on the
Rocks
MRC building,
always
we want to
fall.
kill
Somebody
someone.
drop it, or is it just chilling and it's just start falling?
Hey, so you want something this cliff, and then we see someone at the bottom, we want to kill them, so we just drop a rock on their head. And see if it works. Would it be negative 16? Sorry.
Falling makes it need a negative.
Yeah, the falling implies it's negative.
So it's like absolute value. I'm saying how many feet it's falling, not that its position is a negative. Does
okay.
that make sense?
Like speeding up, slowing down, you don't need to put negative signs.
There you go. So the scenario, rock is falling. Y equals 16t squared feet in the first t seconds. Solve the problem I've given you. Solve it. And then state for me what it represents with the units, please. With units, please. Two ways of solving it. One is very AP-ish. One is very pre-AP-ish.
Well,
You have it?
I think. Okay, then no, I don't know how to count.
That's 0 over 0. Do you have it, Gerardo?
It was just like, do you want us to solve itself, or do you want us to do it the way the AP would do it?
I don't care.
Oh, why didn't you say it from the first?
I just did. So there's a AP way to do it, and there's a pre-AP way to do it. I just want the answer and then what it represents with units.
Oh wait, so T's left or not T left? Like we're plugging in 0?
H is approaching 0, not the T value. Approaching 0. T value is 2.
Oh, the T value's 2. That's okay. That's why. Okay, I think I got it.
You
now.
see it? Because it's x plus h, and so
Yeah,
it's
I see it now. I got it now.
Now what?
Yeah. Okay.
Jackie, did you get it? A little bigger. Bigger? Really?
Alright. I think so. It should be.
Where's your answer?
Right there. I mean, it's not the answer. I haven't told you what it represents yet.
The answer is a single constant.
What?
Let's plug it into this. Did I write it wrong?
I don't know what's going on here. Oh my goodness. I get it. Done.
There it is. I have 2 right ones.
Is this right, Wesley?
Well, 3 right ones if you count me.
I think I did it right.
No.
Should we just this one?
Oh, too big.
What?
Too big.
Oh, okay. There we go. Now I'm right.
What is it?
64.
And how do you do that without having to FOIL or combine or simplify or
How
cancel out the
right.
h's or
Power
plug in? See that it's really just a derivative, right? Derivative of what?
Y equals
16.
Y equals 16 squared. So I could have just gone ahead and found the absolute value of the velocity at 2, which would have been the absolute value of, which I guess it already is absolute value. It's talking about speed, not about, anyway. 32 times
Will we
2
write if we said instantaneous speed at point x equals 2?
at point x equals 2? Just keep it in context of the problem. So since it's 16t squared, you need to say t equals 2. Does that make sense? But my ones that we're solving, does it work out if you had done it the long, old-fashioned FOIL combine, cancel out the h's, plug in h is 0?
Yeah.
I think so. Did it end up working?
It should.
Almost. I didn't finish it.
Oh, okay. Yeah, I think it ends up working. So anyway, long story short, instantaneous speed means limits. And that's where our book is like, hey, limits are important, so let's go ahead and learn them. Yay! Okay, limits. Here we go.
I like what side of it
All right, real quick. One-sided versus two-sided. You guys know one-sided, yeah?
Yeah.
So if I am coming from the left, we'll say left of A, it's going to be A with a little negative, true?
Yeah.
And then if I'm coming from the right of A, it's going to be A with a little
Negative. Or positive.
positive. And what I'm talking about is if I'm coming towards A for function for limit. True? What does it take for a two-sided limit, which is basically every limit without special symbols symbolizing a one-sided limit? What does it take for a two-sided limit to exist?
Both
Limit
sides have to
approaching the
agree.
left, approaching from the right, and an actual point.
Exactly. The limit, that's continuity. Careful, take away the point at the end.
Just kidding, minus the point.
The limit exists if
Oh,
the limit as x approaches a negative is equal to the limit as x approaches a positive, which will be the limit as x approaches a. Does that make sense?
Yeah.
The limit only exists if the one-sided limits agree. So, similarly, if the one-sided limits do not agree, then the limit does not exist. Or, as the AP would say, possibly the limit is non-existent. Same thing, right? Non-existent, limit does not exist. Same deal. Why do they say that? Think about it. Limit is an equals, the proper grammatical way of saying it. The limit is non-existent. What we say the limit is DNE, the limit is does not exist, is awkward.
Who needs English? We're in
Who needs
calculus.
English? We should sue.
We should.
Just kidding.
Would that be a state matter or a federal government matter?
Who cares?
I do. Because I'm filing
well, it's a
a lawsuit.
school, so it technically.
We pause the video. Hello again, Joyce.
Okay. The limit as x approaches.
Misty.
Huh.
At f of 1, is that non-removable discontinuity? Just trying to refresh my mind.
Yeah.
Okay, cool.
That's what we want? No, if there's a hole, it's removable, isn't it?
It'll be removable on one portion. Well, this is set up by a piecewise though.
There's a hole at 1, that's equals 1.
If it was like a function, then we could state whether it was removable or non-removable. You know what I mean?
Mhm.
Okay. You guys have this page open? Can I get rid of it?
Yeah. I don't know why I'm saying yeah.
If anybody ever needs a note, just say so. I'm not ignoring you. I'm just listening to that. One's go talking. Everybody's annoyed by that writing, so am I. There we go. Why did I put the piecewise function below? Normally I just give graphs, but I want you to be able to see what we're doing right with the piecewises.
So
Because you should be able to do this problem with only the piecewise function, or with only the graph, or with both. George, go ahead.
Are we supposed? Do you want us to be doing it with the graph alone, or do you want us to be doing it with?
Either way.
Okay.
With the graph, and then looking down and being like, how could I find it without the graph? So with the graph, 1 from the left, what would my answer be?
0.
Yeah.
0.
How could I get that exact same answer from the function without the graph?
I'll plug it into the.
Match the 1 with the separator 1 with the area below. Does that make sense? And then I go ahead and just plug it in, so then negative 1 plus 1 would be 0. Check. Okay, how about 1 from the right?
Doesn't. Oh, it's 1.
Right? 1 from the right is approaching a height. Now, it does have a point there, but that's irrelevant. It's approaching a height of 1. How do I know? Based on the function. Locate 1 above, right? Locate the portion that talks about numbers greater than 1. Plug it in, well, it's 1.
Yeah, 1.
So then, what's my limit as x approaches 1?
Non-existent.
Yeah, non-existent, or DNE.
Can you put any in there?
For NE instead
Because
of...
the Patriots don't.
Can you at least erase the equal sign?
No, the limit is non-existent. Now it works. If I put D and E, then it'd be improper. So then think about it. Just a quick reminder. How do we think about the limit coming towards a separator in a piecewise function? We have to look at both sides, yeah? Limit as x approaches 2. 2. 2. No. Approaches 2. What do I have to look at?
Before 2, so.
Before 2. After 2. That's 1. Plug in 2. That's 1. Oh, hey, look, they're both going towards 1. But what is f of 2?
2.
So is the function continuous at 2? No, because the limit does not equal the function value. So that's continuity coming soon. So math classroom. Alright. Now, hold on. I don't really think you need to write down this page. Okay? I just want you to think through it. Finding the limit. The very first thing we always should try to do is plug it in, and it works many times. Question. Could plugging in ever not work for a normal polynomial?
No.
No, he's good. How about a rational function?
Yeah, that might
We have to be careful for Q of C not equal to 0. If Q of C equals 0, we'll come back to it. Radical!
No, we have to be careful.
We have to be careful, but
No,
only
domain.
when
It's an even root.
it's an even root. If it's an odd root, do we have any problems?
No.
It can be for all C. It doesn't matter. Because odd has a domain of, remember, cubed root of x. It's fine. If it's even, I have to be careful. Whatever's under the square root has to be greater than 0 if you want to think about it. If I had the limit as x approaches 0 of square root of x, it's 0, right? It's a two-sided limit. Can I come from two sides of square root of 0? Right? It only has one side. Now, if I put a little plus there, it would be 0. But right now, technically, the limit does not exist. I'll take away the equals for microvariance. Does that make sense? I can't come from the other side of a function if it's not in its domain. Composite function. It's pretty much good as long as I'm within its domain. How about trigonometric within its domain? How about transcendental with ln's and e to the? As long as it's in the domain.
I have 2 questions.
Trigonometric and logarithmic and exponential are all transcendental
For
functions.
composite function, it has to fit in the domain of the new and the 2 originals, right?
Has to fit in the domain of the original and then being plugged into the outer. So the inner and being plugged into the outer.
Okay. What if it fits the domain of the original 2 functions, but it doesn't fit the domain of the new composited function?
Then it doesn't work.
Okay. And then on the radicals, at x equals 0, does the limit not exist because it can't go from the left?
Right. But if I had a little plus, then the limit would be 0 because it can come from the right.
Even though it is 0. As you approach
The function
0,
value is 0, and as you come from the right, it's 0. But technically, based on definition of a limit, without some sort of addendum, which there are addendums, we would have to say technically two-sided limit does not exist.
What's an addendum?
A little add in a corollary, like in geometry, there was the corollary to the postulate of the theorem.
So like x has to be greater than 0.
Oh, like you just like it's just like yeah, okay.
All right. If you need to remember, I would write it down. We have 6 minutes. We're good. Okay, so the first step, technically, solving limits, direct substitution, plug it in. Usually works. So then, quick reminder, what if we get 0 over 0?
Try and factor out the values.
Keep going. Why keep going? Because 0 over 0 is not an end-all. 0 over 0 doesn't mean it doesn't exist. It means, I don't know, it's not really an answer. It's not really a value. There's something else going on, and what's the something else going on? Usually a hole. Usually a hole. Jordan.
Do we have to write kg?
Yes. She makes us.
I do.
Oh.
She marks us down, I remember. Trust me, I remember.
That's kg. It's not that long. You don't necessarily need to write all this down. This is something that last year would have taken like 4 slides, 5 slides, 7 slides? I don't know. Something. Dividing out. What do I mean? You can factor. What if you can't factor? It's a cubic, it's a quartic. Do synthetic or do long division. By long division, I mean polynomial division, yeah? What if there are rationalizing? When do we use that?
when it's like 2x over, or 2x over x minus something.
If there's a square root somehow present in the 0 over 0 part.
Wait a minute. Why is it a root in the bottom like irrational?
Remember, that doesn't really matter. Not at our level.
Oh, really? Sweet.
Simplifying complex fractions. Or trig. How are you going to simplify trig?
L'Hopital's. Oh, identities.
Yeah, Matthew's properties. Now, technically, the nice thing is, since you guys did a lot of hard work on your summer packet, getting Gerardo up to speed and then you guys reviewing, technically with 0 over 0, what else can you do? George was right. Mhm. This is also a good application for, and also a good chance for me to go ahead and let you know that on the AP, it's no longer going to be L'Hopital's, it's going to be Le Hospitals. Why? Because in French it sounds like L'Hopital.
Wait, we have to write it out.
I'm just saying the AP is going to have an S, don't be confused. That's all.
Oh, okay.
And L'Hopital's remind me, when we use it, when we get, or
Indeterminate
plug in
form.
and we get indeterminate, we're allowed to take
The
derivative
derivative
top.
top.
the top and the bottom separately and then plug in the limit again. True?
True.
Okay. What's going on if we plug in and get a number over 0?
Yeah, going
Infinity.
infinity. Plus
Infinite form. However, does that mean the limit equals infinity?
No, not necessarily.
Not necessarily. What could the limit equal if you plug in to a function and you end up with a number over 0? The limit either
does not exist. Does not agree.
Well, it could be either DNE or infinity because they could be going to the positive infinity or they could be going to opposite infinity.
so either it agrees going positively at a vertical asymptote, it agrees going negatively at a vertical asymptote, or it disagrees, therefore, hence DNE.
At 1 over x squared is the one where they both agree, right? They go to the same thing.
That's one example. Yeah. So DNE would be something like, positive infinity would be something like 1 over x squared is a great one. Negative infinity would be negative 1 over x squared. There you go.
Cool.
I know we're
We should
cool.
be calculus cops.
So we have indeterminate, we have infinite. Then we're done? Real quick.
Special trig limits. I like that.
What do we do with the special stuff?
Sinu.
Me,
Oh no, I can't delete the page. You didn't delete the
oh,
page.
squeeze serum. That was so fun.
Oh, squeeze theorem.
Transcendental functions, trigonometric, exponential, logarithmic.
Oh, I know which one it is.
What properties can we use or look back to for trigonometric? Forever card number?
2.
Yeah. Or B, or whatever it was.
It was 2.
Forever card number, pre-count review. Now, be careful, double angle of sine. Ooh. Along with the Pythagorean and others.
Oh, you're talking about the identities? Yeah, that's appendix.
Yeah. Cosine squared plus sine squared is 1. Sine 2x is equal to 2 sine x cosine x, etc., etc. Question. Why do I have use?
Because it's like the argument. So
It's
that-
like the argument. So like,
if you
go ahead.
equal- If you equal x minus 1, or x minus 1 squared, quantity squared.
Why does this fit? Because I have a sine of u over a u, and what's u approaching? Wait,
One. Oh,
x
no.
minus 1 approaching 0, that's x approaching 1. Does that make sense? Think about it. U approaching 0. Would be x approaching 1.
Oh, okay,
Does that make
makes
sense?
yeah.
So then I am able to say that this final answer is 1. Now, technically, could we do 0 over 0 L'Hopital's again?
Yeah.
Yes. Which one would L'Hopital's not be nice with?
3.
Yeah.
Because we can't even do L'Hopital's, can we?
He's a new special limit. Da-da-da-da. Gerardo, your wish, my command. We'll make him an endeavor tomorrow. I'll get the polar endeavor up. That'll be endeavor number 1, and I'll get the special limit. We'll probably put all 3, just because, I don't know, you guys could use good feeling at the beginning. Well, you've L'Hopital's, right? No big deal. Homework! Are you going to have limits? Yes. Are you going to have average and instantaneous rates? Yes. When do you have limits? Can you always use L'Hopital's?
Not
No, so keep your wits about you. It might not be a bad idea to solve some of them the old-fashioned way, but if you can do L'Hopital's, go ahead. Except with complex fractions, I'm not sure L'Hopital's is the best. All right, have fun with homework. Homework number 2. No, 3 to tomorrow.
3.
George, should we go homework tonight?
Yes.
Or was it finishing what we did over the weekend?
Yeah, like that was the thing. Like she had it on the weekend.